let me call you. So I want you to solve this in less time, not like lengthy mathematics approach. Draw the diagrams, sir. Draw the diagram. Diagrams are not there. There are two concentric coplanar rings. Outer ring as radius, the inner ring as radius 1 millimeter. I'll draw a bigger ring. This is one ring. We have another ring. So even it's in fact very small for our convenient purpose. I'm showing it a little bit bigger. This is a radius. The inner ring has radius 1 millimeter, resistance 1 ohm. Okay, we'll just indicate here so that it'll be easy for us. R1 I'll call it, and it will also have inductor. There's no inductor connected because see, any current carrying loop will have inductance. Don't think that some extra inductor are connected. This will be wrong idea again. The loop will have inductance. Any current carrying loop, I think there's a definition. No? What is self-inductance? Flux linking to the current flowing through it. What is the flux linking it? B into pi r square or pi a square. What is B is equal to? Mu naught I by 2a pi a square I. So this will be mu naught pi a by 2. This is the self-inductance of that inner ring. Agree this? So that L1 is what I'm showing here. Let's assume there's a background. Huh? Don't think that extra inductor is connected. Or else just write L1 and R1. I'll remove it because I think there's not a correct convention. Let me write here, huh? but your imagination should be like this. So later on we'll write equivalent circuit if it's there. So write nearby L1 and R1. So what is L1? 2 microhenry, R1 1 ohm. Okay, fine. This is initially the inner and outer rings have current and 2 ampere respectively in clockwise sense. Both are having a current. This is carrying a current I1. This is carrying a current I2. Small letters. In clockwise sense. So there's a 5 micro ampere. What else? Later on, current in the inner ring is found to be 3 ampere clockwise, whereas for outer ring it is 5 microampere anti-clockwise. Later on is telling a. Okay, let me take same diagram. Clockwise. And this is anti-clockwise. So I think final current, let me show capital. Three ampere. Outer ring 5 micro ampere. If total charge flown through the inner ring till this moment is Q0 microcoulombs, comma, then find value of Q0. I will push everything to one side so that writing space will get. So this is later on. This is initial later on. This is the initial. Okay, this is the initial. Initially, inner ring is 2 ampere. Initially, the outer and inner rings have current. Outer and inner rings. Oh, sorry. 2 ampere. Okay, yeah, good. Yeah, this correction we need.
Five into 10^6.
Answer? Huh?
Current, sir.
That I2 is
I2.
Micro, no? Micro means 10 to the power of 6 plus 6. Oh, mega, right? Yeah. 10 to the power of plus 6. I didn't see. Okay. Really very sharp. We have to, no, we should not get into mathematics here. The problem is intended like that. You may solve mathematically, integrate everything you do, you'll get answer. But the question was not intended to do like that. That's what I feel. Okay, this I think only one help. What is help? This is our help. This is our, I think, the best condition available for us. Take help of this. If A is not very much less than B, no, not we can't do this problem again. Okay, we'll do one thing. So whenever we had a question of flux, like a charge, how much of charge flown through when flux changes. So I think you recollect this particular problem. Like if this is this particular ring is having a resistance, so this is having a radius C, this is a B bar. Okay, let me do one thing. So this is a B bar. This is 1, 2, 3, 4. I will invert the loop. I don't know how I'm showing. This will be. I'm trying to generate the idea to do this problem. B bar is everywhere into the plane. So this is 1, 2, 3, 4. I will rotate it. I will rotate. So after rotation, the loop, I'll rotate it by 180 degrees. When I rotate by 180 degrees, will it be B bar direction will not change. So this is having a resistance capital R. Let's assume that one. Can you say what is the flux linking? So initially flux is, let's assume that n cap in the direction of that. Finally, what will happen? The n cap will be opposite to this. So what is the initial flux? B into L square. What is the final flux? Minus B L square. So what is the change in flux? Can we calculate how much of charge flown?
7.
I think I gave one method that there's a very easiest approach to that one. So we know I equal to E by R. I is dq by dt. So how much of charge flown through the loop in this square frame loop is change in flux by resistance. Shall we bring similar thing here? I'm not rotating the loop, but I'm changing current. This is rotating loop idea. Loop is rotated by 180 degrees. So I think everyone knows this. It's a very, very silly problem.
3.
Answer you Q naught 3
Sir,
microcoulomb.
3.
I have from where I'll okay 3 microcoulomb. Okay, I'll continue now. Okay, let's get into the discussion. I think we have to search very fast. So there'll be like, due to look at the current I2, it was 5 microampere. I'm going to change the direction of current now. So due to that, what happened initially, it will link a flux. So tell me like, what is the flux linking? So what is the magnetic field at the center of the loop? Mu naught I2 by 2B. Then the direction of current changed. So what happened to B bar? B bar has changed. So flux linking this inner loop will change. Due to change in flux, EMF will be induced. Due to that EMF induced, the current will flow. Look at the current earlier, 2 ampere, now 3 ampere is flowing. So definitely some additional charges flow. That charge flown has to be determined here. So how do I to proceed here? So change in flux. So should be equal to, I'll write here, EMF induced in the inner loop A minus, okay, there'll be flow of current I into R, as it is having self-inductance L di by dt. What is the EMF induced in the inner loop? Change in flux. We'll take it like this here. So I into R L di by dt. Let me write in this form. So delta phi is equal to I dt into R. So dt get cancelled. So di. Now what is I dt? Should be the total charge flown, Q naught R. Or delta Q, what will be that one? Till moment this is Q naught. So let me write that is equal to L. This di is what I should find out. And what is the change in flux? So how to get the change in flux? Flux linking, change in flux linking the inner loop. Delta phi. What is the flux linking this one? Mu naught I2 2B into pi a square Okay, there's a flux linking, change in flux linking the inner loop. I'll substitute here. What is DI? DI, where is the DI? DI is so in the inner loop, no? So how much change in current in the inner loop from capital I1 to minus I1? So this, let me substitute all the values. Mu naught pi a square 2b di. So di should be equal to, solving this, we'll get expression for Q naught. So I think is asking us to really analyze. Don't get into mathematics integrate. Huh? First of all, why we write this equation? There's a primary question what we have to ask. Okay, fine, sir. Okay, you told method, everything we are answered, but how to write this equation?
You can take equivalent circuit.
It's equivalent. Still, okay, due to change in current here, flux linking the inner loop will change. Due to varying flux linking inner loop, there'll be EMF induced. So this is like a RL circuit. So inner loop will behave like a RL circuit. This is the idea. Inner loop behaves as a RL circuit energized by induced EMF. Is that okay? I think I don't have explanation more than this, sir. Mutual inductance, you check the advanced paper. Several times he is asked, and every time is coming with different ideas. So possibility of asking even like this also. You have to be very specific about mutual inductance. Mutual inductance, induced electric field. The priority should be of from here. Three, or I think how much I told answer. Let me write it.